I guess here is the first part of the notes 3B.6. The next triangle congruence theorem that we were going to discuss is going to be your angle side. So we're going to go ahead and start off with talking about how this is going to end up being, as we know, this is going to be angle side. Okay. And what this is going to be, it's going to be your two angles and a non-included side. So unlike the angle side angle, we do not want this side between the two angles. So you're going to go to an angle, you're going to skip a side, go to another angle, and then grab a side. So you're going to actually do some skipping around here. So what this would look like is if we use those same two angles, this angle is going to be congruent to this one. The top angle will be congruent as well. So what we're doing is we are not including the side here like we did over here. Now we're going to go from an angle to a side. So we're actually going to skip over a side before we get to it. So we have to go in the order angle to an angle, then to a side. So these two would be congruent right there. Okay, so please make sure you're noticing the difference. I know in my class I was telling students how I love angle side angle because whenever you have the two that have the two A's, angle side angle is easy to see because it's just one straight line. Angle side angle, no skipping around. This one, you're going to go to angle, skip the side, go to the next angle, then go to the next side. Okay? So let's take a look at the foldable now. We'll do the same thing we've done on the outside here. And we will mention first, we want the angle, so we have angle A is going to be congruent to angle D. Skip that side. We want the next angle, angle B, will be congruent here to angle E. And then we go to a side. This is not included between the two angles. That's why we call it the non-included side. So then we would say segment BC is congruent to segment EF. Okay, and up on the foldable we see that non-included again. Down here as well. So it's important to look at the differences between the two triangle congruence theorems that have two angles in them. So if we see this occurring, we know that triangle ABC will be congruent to triangle DEF. Please make sure that you are pausing if I'm going too fast. We will take a look at our first proof. And again, we are now seeing a lot with empty statements because we need to learn how to fill these in to help a better understanding of how these proofs actually do work. First thing here is segment YZ, right here, is going to bisect angle WYX. So that's going to create two congruent angles there, as we've discussed. And we're going to write that little A in there, circle it. And we all know the first reason. Now we move down to the second step. We need to fill something in the statement that meets the definition of the angle bisector. So basically what we're saying is when segment YZ bisected this large angle WYX, what happened? According to the definition of the angle bisector, we wound up with two congruent angles. So we need to make sure that we're saying that those two angles are congruent. So that's where we come up here and we say, okay, when we bisected angle WYX, came out that angle WYZ became congruent to angle XYZ. And we know those are congruent. We mark them congruent because of the definition of the angle bisector. Statement number 3 claims that angle YWZ, right here, will be congruent to angle YXZ over here. Remembering two arcs because we have the second congruent angles. And what is our reason for knowing this? Well, I don't really see anything up here that helps me, so I need to make sure that I go back up here, and this is going to be another given. Statement number 4, we need to figure out some congruency statement over here that is the reflexive property. So we know the reflexive property is going to be the exact same thing on both sides of the equal or congruent sign. So we've also learned through these proofs in this unit that this is going to be those shared sides. So if we look up here, we notice that both these triangles share segment YZ. So that would make this congruent, giving us an S. So this is the segment that's going to be congruent to itself. So we would say segment YZ is congruent to segment YZ. Okay? Our next statement is now saying, hey, my triangles are congruent. Triangle WYZ and triangle XYZ are congruent. So that's where we go up here. Every time you have the two triangles congruent, we need to figure out which of the 5 congruency theorems we have. Look up here, and we see that we have 2 A's and an S. So we know it's either going to be AAS or ASA. And again, this is why I like ASA is because it'd be in a straight line. Here, we're not in a straight line. We curve around. We have an angle followed by an angle, then a side. And this side does not connect to both angles. So again, if it helps out, you can always cover up one of the angles. I'm looking for my little Post-its. Or sorry, one of the triangles to help see exactly what's happening here. Okay, we are not including this side. So therefore, we don't have angle, side, angle. We have angle, angle, side. Pause, rewind if you need to, please, because I'm doing these videos pretty quickly. The second proof here states that segment JL, so this guy right here, bisects angle KJM. So KJM. So we're going to make sure that we mark our congruent mark since we already know what that means. And no reason to discuss the first reason. We have this definition of angle bisector again, so we're practicing exactly what we did up here. What happened when this bisected? It made 2 congruent angles. So over here, our statement needs to say that we have 2 congruent angles. So we have angle KJL is congruent to angle MJL. Notice the order of letters I'm going in. Okay? And we know that those are congruent because of that word bisects. And that's our definition of angle bisector. Number 3 is completely blank. So what I'm going to show you is a little trick. When we keep moving forward, there's something that's not over here. Look up here. We have another given. So we're going to go ahead and fill that in. Say that angle K is congruent to angle M as our second given. And then we want to make sure that we come up here and we mark that angle K is congruent to angle M. There's another A. Statement number 4 says the segment JL is congruent to segment JL. We are really good at this now. The segment is congruent to itself. So we've got a side. We know that this is our reflexive property. Five is blank, but look over here. We're stating that whatever's going on, whatever's said, the statement that is said, we know that we can say it because of the angle side congruence theorem, because we have an angle side. So every time that in your reasons you have one of those theorems, we need to state that the 2 triangles are congruent. So here we could say triangle JKL is congruent to triangle. Now we need to keep our corresponding parts together. J is going to correspond, this triangle is going to correspond with J on the bottom triangle. K, what we had here, is going to correspond with M, because we can see that these are congruent. So M would be the next one. And then L will correspond with itself. We take one more step and we're saying that segment KL right here is going to be congruent to segment LM. We have already proven that two triangles are congruent, and once we have proven that two triangles are congruent, we have something that tells us that all corresponding parts of congruent triangles are congruent. Your CPCTC. Your last proof on here. See parallel lines, and we know something may happen here. Okay, we know that we've looked on our half sheet and we've seen where we see parallel lines. We may run into one of these. This one will start off with segment LG is parallel to segment JM. So we want to make sure that we mark those parallel. Statement number 2 is saying that H is the midpoint of segment LM. So right here is going to be the midpoint of segment LM. And we know what that does. Creates two congruent segments. So we have a side labeled. And how do we know this? Well, this is one of those things that has to be given to us. Statement number 3 is claiming that segment LH is congruent to segment MH. Well, we already have that marked. How did we know to mark that? That word midpoint. So we have that definition of midpoint. Next, our statement says that angle LGH, so this angle right here, LGH, is congruent to segment MJH. Well, we need to take a look at this. It's not a given, but there is something else above in a statement that can help us out. And this is where we see those parallel lines. And we extend those out. We then have our transversal right here. And that transversal right there is going to give us our two angles that are congruent, and they are alternate interior angles. Alternate sides, interior to the parallel lines. So we have our alternate interior angles theorem. The next statement is claiming that angle GHL, right here, is congruent to angle JHM over here. And we see that they are vertical angles, and we've seen this a lot now. We know this can be our vertical angles theorem. Make sure that we're marking our A's and our S's. And we can take a look here at our triangle. And we can see that the S is not between the two A's. That congruent side is not between the two congruent angles. So the S cannot be between the two A's. So we're going from an angle to the side. So this will be your angle, angle, side.